Okay guys, let us look at one more problem on a system of 3 by 3 equations. And here we have the three equations right here. Now, please look at the equations carefully. This is 2x plus 3y minus 2z. So x, y, z are aligned nicely. Here I have x plus 5y. The z, there's no z term, but x's and y's are aligned nicely. Guys, but if you look at the third term, I have z first and x next, and then there's no y, which is fine. You cannot, I mean, sometimes you may not have a y term. But guys, the first thing that we want to make sure is that they're aligned in a proper way, which means the x, y, like x is first and y is second and the z is next. So first two are already aligned nicely. So this one, we can kind of realign this, not so difficult. We're not going to change anything here. All we are going to do here is we are going to, instead of writing 4z minus 5x, I'm going to rearrange this as minus 5x plus 4z plus 4z. Okay, and there's a missing y term here, which is fine. Sometimes you may not have a y. Okay, so that's the first thing that I would like to do here. Now we have to think about the solution method. In my previous example, we were able to see that all the three equations had x terms, y terms, and z terms, and then we were able to pair two equations at a time and get rid of one of the variables or eliminate one of the variables, and then we had a system of 2 by 2 equations, and we knew how to solve that, right? Now this is slightly different than that one. I mean, you can think of this as type 2, as I like to classify these things as types. So you can think of this as a type 2 example. Now, what we can do here is, again, there's few different things you can do and few different ways of solving this. So when I look at number 2 right here, I can see that from number 2, it should be pretty easy for me to actually solve for x, right? Let us go ahead. Since that seems like it is easy for us to solve for x from number 2, let us go ahead and actually do that one step, and then we'll go back and look at the equations and see if that is going to lead us to something useful, okay? So from equation 2, let us solve for x. Solving for x simply means that we have to subtract 5y from both sides. So it's going to be x equals to 9 minus 5y, right? We just simply subtracted 5y from both sides. Now once I have x equals to 9 minus 5y, now let me think about it. If I substitute that x in equation 1, what's going to happen? I'm going to get rid of the x, and I'm going to end up with an equation that will only have y's, because there's already a 3y, and then I can combine the y's, and then z. So that means if I substitute this back in equation 1, I will get an equation which will have a y term and a z term, correct? Again, if I substitute this x in the third equation, what's going to happen? Again, I'm going to get rid of the x. Instead of x, I will have a y term, and then I already have a z term. So what happened here? By substituting this value in equation 1, I get an equation in terms of y and z. Same thing happens with the equation 3 when I substitute this value for x. I get an equation again in terms of y and z. So that means I'm getting two equations with two variables, and we know how to solve a system of 2 by 2 equations where we have two equations and two variables, right? Guys, the idea or the key concept is still the same. You start with a 3 by 3 system, you want to somehow transform that into a 2 by 2 system. And once you have 2 by 2 system, then we know how to solve that 2 by 2 system. And if you really think about this, with the 2 by 2 system, again, what are we trying to do with 2 by 2? We're trying to transform this into a one system, like 1 by 1 system, just one equation. We solve, and we know how to solve one equation, right? We solve that one equation. From the solution, we can find the solution for two equations. From that, we can find the solution for 3, and so on and so forth. And that is the kind of idea that the computer algorithms and softwares use when they have to deal with system of 100 by 100, 1000 by 1000 equations. And believe me, they have to, in the real world, to do these big things. People are working on these systems of like 1000 by 1000 and million by million systems. Okay guys, let's come back to our 3 by 3 system. So we're just going to do what exactly we talked about. We're going to substitute the x for here and here. So let's see what happens. So once we substitute in this equation 1, and I'm going to rewrite that step carefully, it's going to look like 2 times 9 minus 5y. Okay, I replace this x by 9 minus 5y. You want to put that in parentheses, plus 3y minus 2z equals to negative 1. Right, nothing else changes here. When I simplify this, let us go ahead and simplify this further. It's going to be 18 minus 10y plus 3y minus 2z equals to negative 1. Simplifying further, combining like terms, so this and this is negative 7y minus 2z, and I'm already going to take this to the other side by subtracting 18 from both sides. So when I subtract this 18 from both sides, it's going to end up with negative 19. Guys, I have three negatives here, and I don't like to work with negatives too much, and there's a way for me here to get rid of the negatives, and the way is to either multiply both sides by negative 1 or divide both sides by negative 1, okay? So if I divide both sides by negative 1, negative 1, negative 1, sorry, negative 1. So what do I get? Finally, I will end up with an equation like this, 7y plus 2z equals to positive 19, okay? Guys, you don't have to really do this step, but I highly suggest and encourage you to do it, because this way you will get rid of the negatives, you will end up with all the positives, and it's always easier to work with positive quantities, okay? So I have this equation, the first equation transforms into this equation. Now let us substitute this x in the third one and see what we get. So when we substitute this back in the third one, and let us take it up here, I have negative 5, and then x will be replaced by 9 minus 5y, 9 minus 5y. I still have to add plus 4z equals to positive 4, simplifying this as well by distributing 45 plus 25y plus 4z equals to 4, and I combine, sorry, there's nothing to combine here except for you want to bring that 45 to the other side, so it is 25y plus 4z, and when I bring it to the other side it's going to be 49. Guys, I have two equations. One is this one, this is the other one. Both are in terms of y and z. Okay, so let us bring these together. Let us write these equations together, and then we can think about what would be the easiest and most convenient way of solving this. Okay, so I'm going to bring it here. It is 7y. They're aligned nicely. Y's with y's and z's with z's. Plus 2z equal to 19. Okay. So our goal is here right now, our goal is to solve for these two. Once we solve for one of the variables, we should be able to find the other two as well. Guys, as soon as I see these two equations, my eye catches this coefficient positive 2, and I think to myself, how can I make, like, the easiest thing to do here would be to make this positive 2 a negative 4, and then if I add those two equations, I will be able to get rid of these, right? So how can I accomplish that? I can simply accomplish that by multiplying this equation by negative 2, okay? I mean, there's other ways of doing it as well, but guys, that seems to be a quicker way of doing it. So I multiply this equation by negative 2. So I'm going to rewrite this. Let me first bring this in. So it is 25y plus 4z equals to 49. I just rewrote that, and then I'm going to distribute this 2 and bring this equation below this one, okay? So distribute this 2. I always like to draw those arrows, so it is going to be negative 14y, right? And then minus 4z, that's what we wanted to get. We wanted to get a negative 4z so that it can cross out when we add those two equations. And then negative 2 times 19, please don't forget to multiply the right hand side by that negative 2 as well, which is going to be negative 38. And we already know what to do with these two. You add these two. This crosses out, and 25 minus 14 is 11y. And on this side, I still have an 11, 49 minus 38 to get y by itself. I know we have to divide both sides by 11. And then from here, I get y equals to 1. As soon as I get my y, then I have to think about finding my, well, first I should find I can find my x here, right? See, because it's already solved for x in terms of y, so I can go back here and solve for x. So I have x equals to 9 minus 5 times y, which is just 1. And if I simplify this is 9 minus 5, which is 4. So I got the value for x, I got the value for y. I still need the value for z now. I mean, I have so many options to choose from, but to get z, let me use equation 3 right here, okay? So to get z, let us use equation 3, which is like, you got to do negative 5 times x, which is positive 4. We already have the value for x. And plus 4z equals to positive 4. Guys, I'm simply using equation 3 here, which is already known to me. I'm substituting the value for x, which is 4. We already obtained it. and we are going to solve for z. So it is negative 20 plus 4z equal to 4. I add 20 to both sides. I get 4z equals to 24. Dividing by 4, you get z equal to 6, right? I have x, I have y, I have z, so I'm going to bring them all together, and you can write them in curly brackets or regular parentheses as you like. So what do we have? I have x is 4, I have y is 1, and my z is 6. This is my final answer. And that is something that I would like you to verify by just substituting this back in 1, 2, and 3 and seeing if the left hand side equals to the right hand side. Okay. So guys, that does it for us for the system of 3 by 3 equations. And now in my next videos, I'm going to start with a new chapter, which is about quadratic functions. And there's a lot of interesting things that we can do with the quadratic functions. And as you may already know, that quadratic functions have a lot of applications in the real world around us. And it is very important for every math student to learn how to use quadratic functions, or for that matter, nonlinear functions, to model situations and then work on those type of problems as well, which involve nonlinear functions. Okay, so guys, practice these 3 by 3. They can be a little bit tricky sometimes. Obviously, we can see that they require a lot more work than a 2 by 2 system, but it's all worth it. And of course, there is other ways. When we are working with 4 by 4 or higher level, you can use matrices. Right now, I'm not talking about matrices. Maybe in future, I'll make more videos where I'll talk about matrices. And then of course, you can use your TI-84s and TI-83s and TI-89 calculators as well. Guys, calculator is always a great tool, and we all need to use calculators. But at the same time, guys, it's very important for each and every math student to actually be able to solve these things to some extent without using calculators as well.